In today's tutorial, we will be simulating an inverting amplifier on LTSpice. Open LTSpice and click on the new schematic button. You will see this new schematic window open, and now we place the components for the simulation. First, we select the op-amps. We use the LT1001 dual supply op-amp for our tutorial here. So we place the op-amp as shown. Next, we have to select the next remaining components. We select the resistances and we place the two resistances, the series resistor and the feedback resistor as shown. Following this, we need to provide the power supplies. So for this, we select the component tab again and we move up the directory and find the voltage source, and we select on that and we place the 3 voltage source as shown. Two of the voltage sources correspond to the dual supplies of the op-amp and the other one corresponds to the simulation input. Following this, we select the ground tab and we ground the terminals as shown. Once all the grounds are in place, we select the connecting wire tab and we drag from the square terminal and drop onto another square terminal. For bends in the wire, you just have to click on the layout window itself. So as you can see, we have joined components, and to connect the feedback resistor, all we have to do is click on that connected wire. A junction is automatically formed. Next, we supply the power source to the op-amp. Wire the circuit so that it is easy to understand and aesthetically appealing. Once the general schematic has been drawn, we specify the component values by clicking on each of the components. To specify the resistance value, we click on the series resistance, right click on the series resistance and enter the value. So for series resistance we put 1K, and for the feedback resistance we select a value of 5 kilo ohm to get an inverting gain of 5. Next, we enter the power supply values as plus 12 and minus 12 volt for the op-amp. For the signal source, we have to specify sinusoidal. For this, we click on the advanced tab, select on sinusoidal, and we can specify the amplitude and frequency value. We use an amplitude of 1 volt and a frequency of 30 Hz for this simulation. Once the circuit is properly verified with all the layout and the values are correctly specified, we click on the Run button to specify the parameters of the transient simulation. So we specify a stop time of 2 seconds and a maximum time step of 0.01 seconds. Then just click OK. So once we run, we see this following plot. This contains all the node voltages. Now we click on the graph.raw window and we remove the default graphs. For this, press on the graph and press the delete button. Then we go to the schematic and we press on a link to get the corresponding voltage waveform. So over here we see the input and output waveforms. The green waveform represents the input and the blue represents the output. As we see from the graph, the input is a simulated sine wave of amplitude 1 volt and the output is amplified by a factor of 5 and a phase shift of 180 degree. This completes our demo for today.